Hey guys, hi, welcome back. So in the previous video, we have discussed the electric field intensity derivation due to dipole at some general point. So now we will discuss the numericals related to all the topics we have discussed. So first we will start with the quantization of charge. All right. So before going into the problems, we will recall what was the quantization of charge, the formula for quantization of charge. Okay. So we have already discussed quantization of charge q is equals to plus minus na, right? And what is quantization of charge? That all the charges are integral multiple of charge of electron. So here n is a positive integer which can take any value starting from 1, and e is the charge of electron, which we know it is 1.6 into 10 to the power minus 19. So this is the charge of electron. Okay, one more thing that we have discussed is the mass of electron, and it was 9.1 into 10 to the power minus 31 kg. Okay, these two values we will remember while solving all the three questions. So now let us see the first question. Here it is said a conductor has a positive charge of 19.2 into 10 to the power minus 19 coulomb. How many electrons are in excess or short on the conductor? So you have a conductor which possesses a positive charge, and the value of the positive charge is 19.2 into 10 to the power minus 19. So you will have to calculate the number of electrons which are in excess or short. Means the conductor has excess number of electrons or there is a short of electrons in the conductor. All right. So we have already discussed that when we have a positive charge, so positive charge has less number of electrons, right? There is a shortage of electrons. So it is a positive charge. So n number of electrons will be in short in the conductor. So that value of n now we will calculate. So the simplification is really easy. We have the formula q is equals to plus minus ne, and we can write n the number of electrons is equals to q by e. So we'll just put the value of the charge given to us in the conductor. It is 19.2 into 10 to the power minus 19. And in the denominator, the charge of electron, which is 1.6 into 10 to the power minus 19. 10 to the power minus 19, 10 to the power minus 19 will cancel, right? And it is 19.2 and 1.6. So obviously we can write it as 1.192 by 16. Just because 10 and 10 will get cancelled. So now on doing the calculation, we'll just cancel first. We'll cancel 2 8s, okay? This is 2 8s, and this is 2 9s, 6s. And we know 8 and 96 will cancel 12 times because 12 8s is 96. So 8 12s is 96. So you can write that the number of electrons which are short is 12. 12 number of electrons are short in the conductor. Clear? So that was the easy problem. Now let us see the second question. So here it is said when dry hair in the comb is found to have a charge of 3.2 into 10 to the power minus 7 coulomb, what is the number of electrons transferred and what is the change in the mass of a comb? So you have a dry hair, okay, in the comb, and that has a charge of how much? 3.2 into 10 to the power minus 7. So first the value of charge is given to us. So we'll write given q is equals to how much? 3.2 into 10 to the power minus 7 coulomb. So next it is that you will have to calculate the number of electrons transferred. That we can calculate using the quantization formula. Just now we have done in question number 1 in the same way. The second part of the question is you have to find the change in the mass of the comb. So to calculate the change in the mass of the comb, when we're discussing about charge, we have already discussed that whenever electrons are transferred from one body to another, suppose from a body A, electrons are transferred to the body B. So in that case, transfer of electrons has transfer of mass also. That means the body A will become lighter and the body B will become heavier, right? So this concept we have studied. So we will just calculate the number of electrons and we will multiply with the mass of one electron and we will get the change in the mass of the comb. Clear? So now let us do the calculation for number of electrons. So n is equals to q upon e. So we have the formula for the charge is 3.2 into 10 to the power minus 7. And charge of electron is the same, 1.6 into 10 to the power minus 19. So this will cancel 2 times, right? So we can write n is equals to 2 into 10 to the power minus 7 plus 19. So on doing further simplification, we can see that this will be 10 to the power 12 because plus 19 minus 7. So 19 minus 7 is what? 12. And greater number is 19, so there will be a positive sign. So these much number of electrons are transferred. Now we will see the mass of these electrons. So the same thing what we will do is that we'll just multiply with this number of electrons the mass of one electron. So the mass of one electron is 9.1 into 10 to the power minus 31 kg. So this is 2 into 10 to the power 12. This is what we will write. And 9.1 into with 2, 2 ones is 2, 2 nines are 18. Decimal is before one number into 10 to the power minus 31 plus 12. So this will give us 9 and 1 with a negative sign, 10 to the power 19 kg. Further, we can write it as 1.82 into 10 to the power minus 18 kg. Taking less decimal, 1 point this side. So this is simple. You can do it in this way also. This is 18.2. Okay, if you're taking the decimal 1 point this side, then you will have to divide also. So that will go to the numerator and it will be subtracted from 19. Clear? So this is the change in the mass of the comb and this is the number of electrons transferred. Now let us see the last question. So here it is said how many electrons must be removed from a metal piece so as to leave it with a positive charge of 10 to the power minus 7 coulomb. So here also you will have to calculate the number of electrons, okay, that must be removed from a metal piece so that 10 to the power minus 7 charge is left on the metal piece. So you don't have to worry about the word remove, just calculate the number of electrons, okay. So for this, the same formula is there, n is equals to q upon e. Value of charge is 10 to the power minus 7. Charge of electron is 1.6 into 10 to the power minus 19. So from here, you can write n is equals to 10 by 16. We can write taking the decimal, okay, removing the decimal. And you will get here 10 to the power minus 7 plus 19. So n is equals to, this is 2 5s are, 2 8s are. So it is 5 by 8. And here you are getting what? 10 to the power 12, right? So n is equals to, you can write it as 50 by 8. Just writing one 10 means I'm doing 10 to the power 11 into with 10. Okay, so that this becomes 50 and we can divide it by 8. So this is 10 to the power 11. So finally what you will do is 50 and this is 8. We know 8 5 is 40, 8 6 is 48, right? Okay, sorry. Now let us see here. It is 8 6 are 48. So this will give you what? 50 minus 48. We can write directly 2. Putting a decimal here and this is 0. So you can write 8 2s are 16. This is 4, then 0. So it is 8 5s are 40. All right. So you can write n is equals to 6.25 into 10 to the power 11. So this much number of electrons must be transferred. You can write it as 625 into 10 to the power 10 number of electrons also. Okay. So I think these questions were really easy. You can look some more problems from any other book and do more sums. Okay. That's all in this video. Thank you so much. Have a good day.